to Examrace. This is the classical mechanics, and we will see the variational principle in classical mechanics. In this classical mechanics, we cover all the Newtonian mechanics. Now we move to the complete pure classical mechanics, and from here the variational principle topic, the classical mechanics starts. We will see the calculus of variation in this. So suppose there is a curve, arbitrary curve in xy axis. Then we have to find the information regarding this curve. Means information regarding this path, or the information regarding their maxima, minimum, that is what we call as extremum. So if we know the y as a function of x, or simple way of y equals to fx, then we will able to find for extremum we just put y dot, that is of x equals to 0, and we will able to find the piece of informations. Okay, means we are able to find the piecewise information or point-wise information when we just put the y dot of x equals to 0. But what happens if we want to find the information of whole curve? Okay, we want to find the information of whole curve, then there is some difference, because when we are talking about the whole path, then we have to see that whether this path is the largest path, whether this path is the smallest path, or what is the nature of the path, that we have to see, and according to that we have to do the calculations. For example, in this path, if I draw or if I join this 1 to 2, then this path from 1 to 2 is the shortest one. Okay, this is the shortest one, and this is the normal curve, or we can say this is the longest path, and we are moved from 1 to 2. But when we move from 1 to 2, and this is the shortest path, I just mark this as x equals to 1. Clear? And from this x equals to 1, a line passes. So coordinate of this is going to be the x1, and let it be y1, and from here it's x1 and y2. Okay, let there is a small area, and this area be ds. Fine, this is small area be ds, and this area is such like this. This is the combination of the point from what we say dx and dy. This is what dy, this is dx. So if someone asks what is the small area of ds, then it's going to be the root of, or it's the length of the small element. Means we find the function of the path, and that function is in the dx square plus dy square. That's it. Why I take this ds? Because as we know the equation of a straight line, and that is very simple. We know y equals to mx plus c. So from here, can I say y is a function of y of x? Simple one. Y is a function of y of x, and if you follow this concept that y is a function of y of x, and at different value of x there is a certain fixed value of y, means can I say for other values of x, y is independent of x, isn't it? So y is independent of x for this equation. Okay, for this equation y is independent of x. To overcome that challenge, we take small element and we just take the function of y and x, and that function of y and x give me the length of small element. So this is what length of a small element. Fine.